I'm either thinking you're very lucky or a genius, because I was watching John Paul speak, and I could have rewritten my talk to follow from what John Paul was talking about, but I've got a different take on it. My name's Timothy Johnson. I'm what is being described as a professional mathematician, in that I am an established mathematician in the Department of Actuarial Science and Actuarial Mathematics and Statistics in Edinburgh at Herrick Watt. I find it difficult to describe myself as a mathematician. The reason being is I did my undergraduate degree in physics. I then worked in industry for 16 years. Problems in the oil industry, there were issues about decision making under uncertainty that I wanted to get a better handle on, and then I just started doing more and more mathematics. I did my PhD at King's College. I graduated with a PhD in applied probability. I do stochastic control, so that's why I'm very interested in the film 21, because that's an issue of stochastic control. And I was appointed as the UK Research Council's Academic Fellow in Financial Mathematics in 2006, and I held that position from 2006 to 2011. Now, the Academic Fellowship Scheme was a scheme that was born out of numerous scientific controversies, notably the MMR immunisation controversy in the UK, genetically modified food, and the government decided in their wisdom that what they needed was to create fellowships to enable, to embed scientists who had a commitment to explaining their discipline to the public. Now, the fellowship scheme was very useful to the university because it provided funding for an academic position. And when I said, what is this public engagement aspect? A third of my time was public engagement. What does that mean? And everybody said, don't worry about it. Just do your maths. Everybody will be happy. Then in 2007, I just realised I'm on camera. Then in 2007, the credit crisis struck. And the credit crisis started in summer of 2007, went through 2008, and finished in 2009. And that really took me away from mathematics. Remember, I'm not a traditional mathematician. I'm coming from practice into mathematics, and I'm having to deal with the issues of the crisis. I took my public engagement responsibility seriously, and I was doing quite a lot of engagement with policymakers, not the public, but policymakers, so press and politicians. I drafted a letter that was sent from this building to the Financial Services Authority because they ascribed the credit crisis to a misplaced reliance on sophisticated mathematics. At the same time, that's the background. Page down. Sort of, I've just moved this slide up to the beginning because I thought it might put a bit of the relevance. This is really troubling for me. And this is a quotation from Andy Haldane to the Parliamentary Commission on Banking Standards. So it's a big commission set up a couple of years ago to say, okay, finance is in a dreadful mess, what should we do about it? Mathematics appears in volume 2 in a few paragraphs. This is Andy Haldane, who's a very measured guy, a Bank of England official, so you can imagine what type, but very measured, recognises that everything he says has impact. Unnecessary complexity, pulling the wool over the eyes of the regulator. So he is being very definite in that mathematics had a detrimental role in the crisis. It wasn't neutral, it wasn't positive, it was detrimental. I find that very troubling. That was published last August. But around about 2008, I was beginning to do my teaching, and I teach financial mathematics derivatives to basically actuarial science students. And what I don't know why, I think it was, I was talking to a journalist who worked for Nature at the time, and he was asking me questions about the origins of probability. And I was going back and looking at the origins, and I'd never done this. And what I noticed is there's a formal equivalence between the Cox-Ross-Rubinstein model, which is one of the main models used in practice, and the Pascal and Fermat solution to the problem of points. We've got about 300 years between the two. And basically, it's using the binomial model to price an option. So there's this formal equivalence, but the difference was in how we conceive probability now to how they conceived it in the 16th century. So we have this formal identification, but the meaning of what the meaning of the parameters inside the equations, that was significant. And the reason it was significant to me is that as a financial mathematician, we are the main employers of Kolmogorov measure theoretic probability in practice. We base all our modelling techniques on abstract measure theory. So we don't relate probabilities to counting, we don't relate probabilities to information. So we're not subjectivists, we're not objectivists, we're abstract measure theory. And so I was interested, okay, if I need to understand, this is important, understanding how I see probability and how Pascal and Fermat saw probability. So I went back, I'm a very bad scholar, but I went back through the scholarship. How does the canonical modern textbook on the origins of probability? In Huygens, the first textbook on probability theory, 1657, probability is defined by equating future gains with present value in the context of fair games. And Edith Dudley Siller, an American historian, has analysed this in the context of Bernoulli's work. And she says, equity among associates or partners, rather than probabilities in the sense of relative frequencies, provided the foundation for the earliest mathematical probability theory. Now this is very significant to me because she's separating the frequentist view from the way probabilities have been used in finance. And so that links into my practice. Going back a bit further, generally regarded as the origin of probability is Cardano's Livy Deludo Alle. And this has always been a problematic text because it's seen as being incoherent in modern conceptions of probability, i.e. the frequentists of the subjective conceptions. And what a Canadian mathematician has done, David Bell has, is considered the Liber not as a mathematical text, but a humanist philosophical text. So relating to Aristotelian ethics. And Cardano had an interesting life. You could make a film out of him. He went mad at the end. And he realised he was going mad, his life was collapsing, and he thought, is it because I was a bad boy when I was young? And he did a lot of gambling when he was young. And so what he wanted to do is understand whether this was God's punishment for his bad behaviour as a youngster. And he said, he did a lot of, when you start reading it, it becomes very interesting, and it's becoming even more interesting for me because of this whole idea of the fairness coming in, gambling being involved, and science. And what he established, and he identified mathematical probability because they identified that equality was established by counting the number of ways an outcome could occur. Go back further. I think one of the most interesting characters in my studies is Pierre-Jean Olivier. And Olivier was a spiritual Franciscan. And this meant today he would be described as a red-green activist. So as a Franciscan, he did not own property, but he argued that you shouldn't use property. You should limit your use of property, so it's usus pauper. He was declared a heretic by the church because partly his views were so extreme, but probably because he supported the emperor in the battles between the emperor and the pope. Occam was a Franciscan and would be related to Olivier. I'm not so sure that Duns Scott is possibly. If you're familiar with the book of the film, The Name of the Rose, Olivier appears in there because they discuss the spiritual Franciscans a lot. Now, the Rhodian merchant is, there's a famine on Rhodes. A merchant has sailed from Alexandria with a grain shipment. He arrives at Rhodes knowing that there are more grain shipments following. What price should he charge to the starving? Should he charge the market price, which is high because there's a famine, or should he reduce his price because he knows that there will be more grain shipments coming? And Aquinas' analysis was that it's reasonable for him to charge the high price. And this was because there is uncertainty in what will happen. The merchant might think there are more shipments coming in, but he doesn't know. Therefore, because there's uncertainty, he can charge a premium. And Olivier disagreed with Aquinas not on the ethical content, but on the way he was approaching it. And he said, you can't predict the future. And elsewhere in his writing, he saw probability as a tradable entity. That is something that could be quantified. And that is apparently the first observation in the Western literature of this idea of quantifying an uncertain event. But it's in the context of commercial exchange. That's where this is all coming from. It's all coming out of scholastic analysis of commerce based on Book 5, Chapter 5 of Nicomachean Ethics. Apparently it's a very problematic chapter. Nobody really understands it. And there's lots of different interpretations. Aristotle's concern is solely with an ethical question. What is the basis of fairness in the exchange of goods? I'm interested in this because Judson's saying it's not an economic analysis, and I see this as Judson's a contemporary philosopher, and I see him as sort of separating fairness from economics, and part of my argument is fairness appears embedded in economics. And then Richard Haddon in the late 90s, building on Franz Bokenhauer, Marxist from the 30s and 40s, and Joel Kay again in the late 90s, argue that this is the origin of Western science. And the idea is because what the scholastics recognized was Aristotle was employing mathematics in an argument, and what he was doing was, money resolves the issue of incommensurability. So typically in Aristotelian science, you can't compare time and distance because they're incommensurable. But money resolves that issue. You can compare Y with cloth through money. And that apparently, according to Borkenau, Haddon and Kay, and others, is important in the development of Western science. Now, so I'm seeing lots of interesting things about fairness and probability, but I'm interested in probability in the context of finance. So what was medieval commercial practice like? And it was surprisingly sophisticated in Europe. Europe had to contend with two issues at the time. They had to deal with strict usury prohibitions, and they also had to deal with the heterogeneity of currency. The Islamic states had the usury prohibitions, but typically a homogeneous currency. The Chinese and Indians didn't have such strong prohibitions on usury, and they also, India had heterogeneity of currency, China often had homogeneity of currency. And there's an example of a trade by, I think it was a Pisan merchant, who was buying wool in Mallorca and selling cloth in Venice, and it involved 5 currency transactions over 5 years. And so these were long-term contracts that were quite complex. The instruments that are associated with the credit crisis existed in the medieval period. Asset-backed securities, because of the usury prohibitions, all commercial instruments had to be asset-backed. They had to be supported by a productive asset. And then special purpose vehicles, it's a technical term, but again, they were collateralized debt obligations are an example of a special purpose vehicle. And they involve the transformation of a random cash flow to a fixed cash flow and an insurance contract embedded in. So layman's failed because they held too many of these special purpose vehicles that weren't as valuable as they held. They were known as the Contractus Trinus of the German contract. They were outlawed by the Pope in 1519, so they were definitely being used. We go back to Fibonacci, Liber Abaci. It enabled the commercial practice. You've got very complex commercial practices going on. They needed a way of managing their affairs, and Fibonacci provided it in the Liber Abaci. And what's important, this comes from Siegler's 2003 translation, and Siegler makes a point in the introduction that the Liber enabled knowledge in the form of best practice to be transmitted and communicated. Arbitration. In Fibonacci, you have this example, and what arbitration is, or the concept of arbitrage, which is the basis of modern pricing, is where money arbitrates between the values of different assets. So it's acting as a mediator, as an arbitrator. If the arbitration isn't fair, then an arbitrage exists. And then this developed in the 17th century, where it becomes formalized in financial mathematics by the Dutch mathematician, politician De Witt in the pricing of annuities. The contemporary fundamental theorem of asset pricing states the market admits no arbitrage if and only if the market has a Martingale measure. It emerged in the late 70s, early 80s, about 8 years after the famous Black-Scholes-Merton equation was published, at about the same time as the Cox-Ross-Rubinstein model was published. Not many people outside mathematics know it, but it's significant in that inside it unifies a lot of distinct ideas in financial economics that were seen as distinct. For example, Merton's use of stochastic calculus was always very different from CAP-M, which Black used, and the two never got on. When you bring in the fundamental theorem, you can see the relationship between the two approaches, and so it's significant sort of scientifically. How do we understand the Martingale measures and no arbitrage? A Martingale measure is a probability measure that establishes an equality between the future and the present. Current price of an asset X must lie between the upper value that it could be in the future and the lower value. If it didn't, an arbitrage would exist. If it was lower than the lower value you'd expect in the future, you buy the asset now, you make a certain profit in the future. So the current price must lie between the lower and upper future prices. And then you can just rewrite it geometrically, and you can say the current value is the expectation using this Q measure. And these are the measures that we use in financial mathematics, the Q measures, these risk-neutral measures that create the equality. And so it's going back to these ideas of Huygens, these ideas of fairness and reciprocity that go back to Aristotle. We don't ever think about it. Nobody. It's a disconcerting hypothesis for mathematicians. I came across this about 2010. I struggled with it because I come from a traditional physics background, from Imperial. Mathematics has no moral content, no ethical content. And I struggled with this for a long time. One of the things I struggled with is, why did it exist and then disappear? I've been fortunate in a number of people outside mathematics have been quite interested in this work. And one of them said that my problem is, up until about 1730, fairness was central to mathematical probability. It declined through the 18th century, and you can see it in the discussion of the Petersburg paradox, which was closed down by Laplace in 1821, when he said that moral expectation equaled objective expectation if there were infinitely repeatable events. People say what you're seeing is this post-Enlightenment objectification and the instrumental mindset. There's another way of looking at this, and talking about the talk we had, potlatch. Potlatch is very interesting to me. And there's an alternative view of this, and that's Carl Polanyi's The Great Transformation, and he talks about potlatch and how, and so the suppression of potlatch is interesting to me in this process. But the dialect of Enlightenment, Adorno and Horkheimer is more interesting for me because of where it leads me. But we'll come on to that. So I'm thinking, okay, that's why it's been lost. Reciprocity is a foundation for financial economics. Okay, is it just a heuristic? There are problems if it's just a heuristic, if it's just an example. This is how we can explain it. There's significant empirical evidence for what's called the ultimatum game. The ultimatum game is you have two players and a pot of money. The pot of money is there. Player A decides on the split of the pot. Player B decides whether that split is acceptable. If it is, it is made. If it's not, nobody gets anything. The ultimatum game is an anomaly for economics because you should accept any split. So if the pot is £100 and I say we'll split it 99 to me and £1 to you, a rational profit maximiser would accept £1 because they're getting £1 for nothing. But this doesn't happen. Or what they found in the late 90s was it wasn't happening. People want a fair split, 40-60 is about as high as they'll go. But they do find that certain very isolated cultures, and Henrik was the guy who observed this first, are objective utility maximisers. They'll just take whatever. Young children will take whatever. Higher apes will take whatever. But we have established this, in societies where exchange is important, fairness is important. And so this is my empirical evidence. And this is interesting. Brendan said that the issue is with neuroscientists at the time. There's a big debate over the ultimatum game about whether it's neuroscientific or social. And I'm coming on the social side. So that's, vaguely my colours of the flag. So reciprocity is a norm implicit in commercial exchange, and it becomes explicit in the mathematics. Apparently this sort of idea comes from Wittgenstein, but it was explained to me in the context of Robert Brandon, contemporary American pragmatist. The explanatory hypothesis. And this is going back to the dialectic of the Enlightenment, and you take it forward and think about things in terms of Habermas. And Habermas said, okay, the dialectic of the Enlightenment is very negative. Can we offer a more positive spin on things? And this is what's important to me, because, to be honest, a lot of this work is about legitimising my academic discipline. And so you think of markets as centres of communicative action, and that implies that they're governed by norms. My result is reciprocity appears to be a norm of commercial exchange. This is important. You mentioned power in communication. Reciprocity is important for, commentaries on Aristotle make this point, that you need to have an equality in power. So that's there. Sincerity is directly from Habermas. The one that I have explored, but I don't go into detail, is charity. And talking about, the reason I've got this is the relevance of the humanities to academic practice. I studied The Merchant of Venice as my O-level Shakespeare. One reading of The Merchant of Venice is of the 4 studies of love. So friendship, erotic, familial, and charity, Christian love. With the Merchant of Venice being a personification of caritas, agape, Christian love. Now that seems really jarring in the contemporary setting, that Shakespeare chose the Merchant of Venice to personify charity. That's quite a startling result. But there are other issues where charity was very important in finance, or areas. In this context, mathematics is the language in the way that Habermas saw language. So it's not a truth bearer. You're not interested in the truth of the statements, but what mathematics is, it enables an achievement of consensus. And again, so in this sense, I see it as a rhetorical device. But what's interesting here is when sociologists look at finance, this keeps on reappearing, how mathematics is used in negotiation. So practitioners don't take the mathematics seriously. They use the mathematics to test and justify. So you observe how they use mathematics, and it's a case of justification. You say, this is my claim, the price is this. They will then justify it using mathematics. Somebody else will justify it using a different mathematical model. This is has quite significant impacts on how finance is practiced, and there's lots of implications. If people are thinking about crowdfunding, there's issues about the regulation of crowdfunding. This is where lots of people get together and fund a project directly, and typically they involve low interest rates. The US has put strict regulations on crowdfunding. It's going through Parliament at the moment. But if you start thinking of markets not as centres of profit maximisation, but as centres of communicative action, reciprocity and crowdfunding become very important. Sincerity. If you're watching what's going on in finance, high-frequency trading, Michael Lewis has just produced a book on high-frequency trading. There is an argument that certain aspects of high-frequency trading are illegitimate because they are insincere. Charity, you shouldn't be lending money to people who can't pay it back. You have to take care. So, what I've learned, mathematical probability emerges out of the ethical analysis of exchange. That has implications to how we treat probability or view probability in dealing with things like climate change, in science in general, where we're thinking about long-term uncertain events. Reciprocity is a norm of market communication. Markets are centres of communicative action. It implies, has certain implications on how markets should be regulated. I did these slides before I came down, but it's what I'm trying to capture here is going back to Haldane's comments. The popular culture is mathematics as a secret language. Mathematics is being used in the markets to place a veil over mathematical practice. We had the issue about insurance and mathematics. Jonathan Levy, who's a colleague of Michael's at Princeton, has published a book a couple of years ago called Freaks of Fortune, where he describes how in the late 1880s the large American insurance corporations were going to the regulator saying, trust us, we use mathematics, which are too difficult for you to understand. Have you read the book? Yeah. And it seems very prominent in our contemporary culture. Pi, the secret's in the number. Well, you know, the secret to unlocking wealth in the markets in the number. Da Vinci Code. Marcus de Soto, their code. It's a code for unlocking the secrets of nature. The Simpsons and their mathematical secrets. It's hidden. And I have a big issue with this hiddenness. And I won't go, I'm diverting from what I was originally going to say, but why is it got, I couldn't read the Da Vinci Code, I couldn't get past page 1 of the Da Vinci Code, because this number, this irrational number is divine, it's special, it's magical. It appears, the Elliott wave in markets, people use it in markets to make decisions. Why is it divine? Why is it golden? Because it's an infinite set of wands, which were religiously significant to Pythagoreans and Neoplatonists. That's why it's divine. It's not divine in that sense, it's divine in that sense. And it's mathematics changes. It's not immutable. If we saw mathematics in this way, in the way that scholastics presented it, we would understand its divinity. Presenting it like this, we don't understand its divinity. Have I got... take a few more minutes if you've got
Nothing to say then.
I don't have anything to say. I want to draw your attention to something. I think it's here. Well, you can't really see that.
in the early 1950s, I was able to locate, by chance, this unknown book by a French graduate student in 1900, rotting in the library of the University of Paris. And when I opened it up, it was as if a whole new world was laid out before me. In fact, as I was reading it, I arranged to get a translation in English, because I really wanted every precious pearl to be understood.
Does anybody know who was speaking? Anybody recognise who was speaking? That was Paul Samuelson, America's most prominent economist, alongside maybe Friedman, of the post-war generations. He's presenting the discovery of the Bachelier, the way he presents. He's presenting it, it's not popular culture presenting it like that. He is presenting it as this. What amazes me is this predates the Da Vinci Code, but it could be a scene in the Da Vinci Code. And it's not a popular representation. It's Paul Samuelson, the Nobel Prize winning, his textbook on economics has sold something like 40 million copies. And that is how he sees mathematics. And I think that is why we had a credit crisis. Thank you.